Hello students, welcome back to the JEE Last Mile Preparation series. In this session, we will solve two more questions. Hope you have solved the two questions that were discussed in the previous session. Let's continue with organic chemistry. The two questions are taken from the chapters Some Basic Principles of Organic Chemistry and Hydrocarbons. Let's move on to question number 3. Okay. Compare the basic strength of the following carb anions. 4 options are given. The correct option will be the one which gives you the correct decreasing order of the basic strength of these 3 carb anions. Okay. Now you know what a carb anion is. A species which contains a carbon atom with a negative charge. And in these carbon ions, this carbon atom will have 8 electrons around it. Okay, it's a reactive intermediate. You're aware of all that, correct? Let's focus on the basic strength. Now, the negative charge on the carbon atom will imply that it can use this pair of electrons to accept a proton, and hence it can act as a base, right? So greater the availability of this lone pair of electrons on this carbon atom, of these carbon ions, towards accepting a proton, stronger will be the base. So we have to find out which of these carbon ions will donate this lone pair of electrons and accept a proton most readily, or will use the lone pair of electrons to accept a proton most readily. Okay. To get an idea about this, you should be aware of what the basic strength of carbon ions depend on. Okay. So the basic strength of carbon anion depends upon the percentage S character. So let's focus on the percentage S character. Okay, you have 3 hybridized states. There are more hybridized states. Let's focus on these 3 hybridized states. In sp3 hybridized state, the percentage S character would be 1 out of 4 into 100, which is 25%. Here, it is 1 out of 3 in sp2. 1 out of 3 into 100, which is 33.3%. And in sp, it is 1 out of 2 into 100, which is 50%. Now, what is the significance of the percentage S character? That will help us to decide which carbon ion will donate or will readily donate the lone pair of electrons to accept a proton. Okay. So percentage S character, greater the percentage S character, greater the electronegativity of that atom. Okay. Greater the electronegativity of that atom. And what is electronegativity? Electronegativity is nothing but the electron attracting power. Electronegativity is nothing but the electron attracting power. Okay? So if any atom has a high percentage S character, its electron attracting power is high. So if you look at the 3 states of hybridization, sp has the highest percentage S character, right? This is the highest percentage S character. As a result of which, this carbon atom, which is sp hybridized, will have the highest electronegativity and will attract the lone pair of electrons most towards it. Okay? So it will tightly hold the lone pair of electrons, and that lone pair of electrons is not readily available to accept a proton. So greatest S character would imply weakest base. Highest S character would imply weakest base. Okay. And the one which has got the least S character implies strongest base. So that is how you determine and compare the basic strength of these 3 carbon ions. Okay. So let's have a look at the state of hybridization of these 3 carbon ions. Focus on this carbon atom. There are 2 bonds here and 1 bond here, right? 1 bond here. So totally, and there is a lone pair of electrons. So around this carbon atom, there are 4 electron rich regions, right? And when there are 4 electron rich regions, the state of hybridization of this carbon atom is sp3. Focus on this carbon atom. Double bond implies one electron rich region. So you have 1, 2, and 3. So this will be 3 electron rich regions, and therefore this will be sp2. Now focus on this carbon atom. It has got a triple bond, which signifies one electron rich region and a lone pair of electron, which is the second electron rich region. So this has got 2 electron rich regions around that carbon atom, and therefore it is sp hybridized. So obviously this carbon atom, this carbanion will have the highest S character, highest percentage S character, and because of which this lone pair of electron is tightly held by this carbon and not readily available to accept a proton. So this will be the weakest base. Okay, now this has got the least S character. Least S character implies that this pair of electrons is not strongly held by this carbon atom and therefore is readily available to accept a proton, making the first carbanion A as the strongest base. Okay, so here we have the option A greater than B greater than C. I hope the discussion is clear to you. So now let's move on to question number 4. Okay, so in question number 4, let's have a look at question number 4. Identify the major addition product in the reaction. You are given an alkene reacting with ICl. Okay, an alkene reacting with ICl. 4 options have been given here. So focus on the alkene. It is an asymmetrical alkene, right? You are aware of what an asymmetrical alkene is. It is an asymmetrical alkene, and this reagent is also asymmetrical. So we have to apply Markovnikov's addition rule. Let's write down this reaction again and see what the product would be. So here we have CH3, CCH3, CH3, CH double bond CH2 plus ICl. Okay. Now in ICl, iodine is less electronegative than chlorine and therefore will be the positive part or the electrophile of this reagent, and chlorine will be carrying a minus charge. Okay. Now according to Markovnikov's rule, when an asymmetrical reagent adds on to an asymmetrical alkene, the positive part of the reagent will get attracted to or will get added to that carbon atom which is attached to more number of hydrogens, or that carbon atom which is least substituted, okay, resulting in the formation of a carbocation. Okay, and you know the stabilities of the 3 carbocations, primary, secondary, tertiary. We're not involving any other carbocation here. You know that a primary carbocation is the least stable. So let's see what type of a carbocation we get in this reaction. Let's write down the equation wherein the pi bond will shift towards carbon atom, as a result of which this carbon atom, the positive iodine gets attached. What do we get? We get CH3, CCH3, CH3, CH single bond CH2I, and this carbon atom will acquire a positive charge, okay, plus Cl minus. So what type of a carbocation have you got here? You have got a secondary carbocation. Okay. Now, whenever a reaction involves a carbocation intermediate, and if you get a specific carbocation, check whether it is possible to get a more stable carbocation. So focus on this carbon atom, which carries a positive charge. if focus and look at the adjacent carbon atom, if this methyl group with the bond shifts to this position, what do you get? Okay, so now what we are doing here is a methyl shift, a methyl shift, a 1,2 methyl shift. And what do we get here? We get CH3, CCH3, CH, CH3, CH2I plus Cl minus, and there is a positive charge on this carbon atom which has lost the methyl group. So what type of a carbocation have you got now? You have got a tertiary carbocation. And you know that a tertiary carbocation is more stable than a secondary carbocation. Correct? So, because of this rearrangement, now the chloride ion will be attracted to this positive charge to give you the final product, the major addition product of this reaction, which is CH3, CCH3. You have a chlorine here, and then you have CH, CH3, CH2I. Okay, so this is the product of the reaction, the major addition product of this reaction. This involves a rearrangement from a secondary carbocation to a more stable tertiary carbocation by a 1,2 methyl shift. So let's see which amongst the four options is the correct answer. Okay, so we have CH3 twice, CH3 twice, CCl, CHCH3, CH2I. So this is the major addition product of this reaction, which is option C. Hope you found these two questions useful. Thank you.